Have you ever stared at a thunderstorm, completely mesmerized by the raw power of lightning? It's one of nature's most spectacular light shows. But what if I told you that each one of those brilliant flashes is doing a lot more than just lighting up the sky? In fact, lightning is a powerful, and often overlooked, player in our planet's climate and atmospheric chemistry. Today, we're going to dive deep into the electrifying world of lightning and uncover its hidden dual effects. It's a story of creation and cleansing, and it's happening right above our heads. So, let's start with the basics. What is lightning? Simply put, it's a massive electrostatic discharge. Inside a storm cloud, tiny ice crystals and water droplets collide, creating a separation of electric charge. The top of the cloud becomes positively charged, and the bottom becomes negatively charged. When this charge difference gets big enough, nature looks for a way to balance things out. The result? A colossal spark that can travel between clouds, or from a cloud to the ground. These bolts are incredibly hot, reaching temperatures hotter than the surface of the sun up to 30,000 degrees Celsius. This intense heat is the key to understanding lightning's chemical superpowers. Our atmosphere is mostly made up of nitrogen and oxygen, about 78% and 21% respectively. Under normal conditions, these two gases don't really interact. They're like roommates who just coexist peacefully. But when a lightning bolt rips through the air, its extreme heat provides the energy needed to break the strong triple bond of nitrogen molecules. Once these nitrogen atoms are freed, they can react with oxygen to form nitrogen oxides, often written as NOx. This process is called nitrogen fixation. Essentially, lightning is a natural fertilizer factory in the sky. Why is this important? Well, nitrogen is a crucial nutrient for all living things. Plants need it to grow, but they can't just pull it out of the air. It needs to be converted into a usable form first. The nitrogen oxides produced by lightning dissolve in rainwater, forming nitric acid. This then falls to the ground and enriches the soil with nitrates, which plants can absorb. So, every thunderstorm is actually helping to fertilize our planet's ecosystems, from vast forests to your backyard garden. Scientists estimate that lightning is responsible for about 10% of the world's naturally fixed nitrogen. It's a vital part of the nitrogen cycle that has been sustaining life on Earth for billions of years. Without it, our world would be a much less green and vibrant place. But that's only half the story. Lightning doesn't just create, it also cleanses. This is where its second major role comes into play, one that has a huge impact on our climate. The same nitrogen oxides that fertilize the soil also have another job to do high up in the atmosphere. They act as catalysts in chemical reactions that produce a very special molecule, ozone. Now, you've probably heard of the ozone layer, which is high up in the stratosphere and protects us from the sun's harmful ultraviolet radiation. But lightning helps produce ozone in a different region, the troposphere, which is the lowest layer of the atmosphere where we live and breathe. In the troposphere, ozone is a bit of a double-edged sword. At ground level, it's a pollutant that can harm our health and damage crops. But higher up in the troposphere, it plays a different role. This is where lightning's cleansing power shines. The nitrogen oxides from lightning strikes lead to the formation of another, highly reactive molecule called the hydroxyl radical, or O. Scientists often call this the detergent of the atmosphere. Why? Because it's incredibly effective at breaking down and removing pollutants and greenhouse gases. Think about methane, for example. Methane is a potent greenhouse gas, over 25 times more effective at trapping heat than carbon dioxide over a 100-year period. It's released from natural sources like wetlands, and also from human activities like agriculture and fossil fuel production. The hydroxyl radical is the primary way that methane is removed from the atmosphere. It initiates a chemical chain reaction that breaks methane down into less harmful substances. And where do many of these hydroxyl radicals come from? You guessed it, from the chemistry kick-started by lightning. So, lightning is in this delicate balancing act. It produces NOx, which leads to the formation of both ozone, a greenhouse gas itself, and the hydroxyl radical, which cleans up other greenhouse gases like methane. It's a complex and fascinating interplay of chemical reactions. For a long time, scientists had a hard time measuring just how much NOx lightning produces. It's not exactly easy to fly a plane through a thunderstorm to collect air samples. But with modern satellite technology and advanced computer models, we're getting a much clearer picture. We can now observe the chemical plumes created by large storm systems and track how they spread across the globe. These observations are confirming that lightning is a much bigger player in atmospheric chemistry than we previously thought, especially over the oceans and in remote tropical regions where other sources of NOx are scarce. This has major implications for our climate models. To accurately predict future climate change, we need to understand all the pieces of the puzzle. If we underestimate how much cleansing the atmosphere does on its own, thanks to lightning, our predictions could be off. On the other hand, we also need to account for the ozone that lightning helps create. It's a complex feedback loop. For example, as the planet warms, we might see more intense thunderstorms, which could mean more lightning. More lightning would mean more NOx, leading to more ozone and more hydroxyl radicals. Would the net effect be more warming or more cooling? Scientists are working hard to answer this very question. It's like a cosmic tug-of-war happening in our skies. On one side, you have the warming effect from the ozone produced. On the other, you have the cooling effect from the breakdown of methane by hydroxyl radicals. The final outcome depends on the location, altitude, and time of year. For instance, lightning in the tropics, where the air is cleaner and solar radiation is intense, has a different chemical impact than lightning over a polluted mid-latitude city. So what does all this mean for us? It means that the next time you watch a storm, you can appreciate it on a whole new level. You're not just seeing a weather phenomenon. You're witnessing a fundamental process that shapes our world. You're watching the sky manufacture fertilizer to help forests grow, and at the same time, produce a natural detergent to scrub the air clean of pollutants. It's a powerful reminder of how interconnected everything is in the Earth's system. The electricity in the clouds is directly linked to the health of the soil beneath our feet and the composition of the air we breathe. Understanding lightning's dual role is crucial for building a complete picture of our planet's health. It highlights the natural cycles that have kept our climate in balance for millennia and gives us a better baseline for measuring the impact of our own activities. It's a field of study that is constantly evolving, with new discoveries being made all the time. From a flash of light comes a wealth of insight into the intricate chemistry that makes our planet habitable. So, the next time the sky darkens and you hear the distant rumble of thunder, remember what's really going on up there. It's not just noise and light, it's the planet's pulse, its chemistry in action. It's a force of both creation and purification, a spectacular and essential part of life on Earth. Thanks for joining me on this electrifying journey today. If you enjoyed this video and want to learn more about the amazing science of our world, make sure to hit that like button and subscribe for more content. Let me know in the comments what you found most surprising about lightning. Stay curious, and I'll see you in the next video.